The purpose of this lab was to observe an object, our water bottle, moving at the same speed and in the same direction, and apply this to Newton's second law, and then create a computational model of the to predict the motion of the water bottle. Okay, my results were that the predicted motion, the ideal of the ball, was pretty much the same as my observed motion in the real world. So we know Newton's second law is that F net is equal to ma. So when we make alterations to this formula, we find equations for V final and the final position. So these will be extremely essential for our VPython script, so it's important to note this. So first thing I did was upload my video into Tracker, and in Tracker I could set the frame, so I knew that in these frames my water bottle was moving at a constant velocity. I also created a Cartesian plane on my video. My x-axis, my positive x-axis, was in the right direction. But if I did flip my axis, the only difference would be that the motion would be in the negative direction, since the negative x would be in that direction. Some key things that I was to take from this tracker thing that I extracted was the initial time, the initial position, the final time, as well as the change in velocity. My change in velocity, I used the initial point in time as well as the 6th point in time. This was just because I felt that was best instead of using the first and last and the first and second. It was more accurate to me. Also, it's important to take this whole time versus position graph because that will be essential later. So for my VPython script, I put the mass as 0.003 kilograms. That's just what I thought. But in fact, the mass doesn't really matter because the F net is 0. And though we know the F net is 0, it's important to note that we don't know which forces are acting on the ball and from what directions they're acting and what magnitudes they're acting with. We just know that the total sum of the forces is 0. So here I put the initial position and the initial velocity. So when we go down, we can see that here are our Newton's second law equations for final velocity and final position. So this should be able to predict our motion of the ball, and let's see if it does. When we run the module, we see that this is the position, the ideal motion of our ball. So when I exit that, I can extract the data from this as well as the data from my tracker and insert it into this Excel sheet and then create a graph. And then when we look at the graph, it is easy for us to see that our two motions are quite similar.